all of you have read what is written on the board? Huh?
Yes.
So now some of your questions, like from a battery, how many charges go out, what controls it, vagera, vagera, all those things you can will be answered today. Okay. Now, as you see here, battery is a system. So in this whole universe, you see chemical reactions are taking place, many actions are taking place because everything wants to become more and more stable. Okay, see what is that stable? You have a bowl like this, and then you have a marble kept here, right? You have a marble kept here. So if you keep the marble here, what happens to the marble? The marble will start rolling down, and then again it goes. It starts oscillating like this. Okay, so you see the potential energy of this point is mgh, and the potential here is minimum. Right? It is maximum here, it's minimum. So it is tending to come to its minimum position. That's why it is oscillating. Okay? Chemical reactions are also taking place because it has to, it will try to come to a configuration where the potential energy of the system is minimum. Okay? So battery also, what has happened? In a battery also you will have charges accumulated here. Okay? Frankly speaking, if the system is neutral, it is happy, right? But now you see there is potential energy in the system. Okay, so this is at higher potential with respect to this. So it wants to lower the potential. How will it lower the potential? You see these two plates, supposing they are uncharged. That is, these charges will somehow flow here, or these charges will somehow flow here, and it will neutralize. Then the potential energy of the system becomes zero. So it tries to do that, but internally there is opposition. The electric field will not allow this to happen. So it is seeking some external path to travel, the charges to travel and attain stability. So therefore, a battery has a tendency to push the charges outside. It has a tendency to push the charges outside. It always has a tendency. So a battery will have this tendency to push, and if there is some provision, that means it is connected with a circuit where the charges can move. Okay, then it will readily move and try to neutralize. Okay, that is first part. Now some charges will move and neutralize. But battery is a system where, as the charges are getting neutralized, more charges are generated. How many charges get neutralized? That many charges are generated by the chemical reaction. Okay, so this is how the battery mechanism will work. But the potential difference between these 2 points will remain constant. It will neither increase nor decrease, irrespective of whether the charges are moving out, how many charges are moving out, or whether the charges are not moving out. The potential difference is always maintained. Okay, charges get neutralized, new charges are generated within the battery. Okay, any questions here? Now stage by stage I am asking. You ask questions stage by stage, and if you want to think, you tell, sir, wait, I will think. Now no more repetition. No, you cannot. See, you that much time it's not there. Aram say. You don't be in that mood that I have to always think. You are a brilliant boy. You will learn.
Means when you once told that sometimes the potential difference might change slightly.
No, it will not change. Now forget that. It will not change at all. It will not change. Forget that. It is all instantaneous. See, change. It does take some time to change, but that time is negligible. 0.00001 second. So for all practical purpose, it doesn't take much time to change. Okay? Because physics works like this. Alright. Shall I move ahead?
And neutralization takes place inside the battery so that the charges are
inside means see, the positive charge will go out here, go here and neutral. Actually, it is electrons. So this plate has got negative charges, this plate has got positive charges. Say one positive charge has gone neutralized, a negative charge. Listen. See, NaCl molecule. Na plus will be there and Cl minus is there. Okay. So when they combine, it combines and forms NaCl. It neutralizes. That's all. But here there is no NaCl. Some other ions or something else is there. Here basically electrons will flow. ठीक है ना? हाँ, right. Any question? Okay, done. आराम से यार, आराम से यार. But don't start digging yourself into questions. Oh, let me ask some question. Don't do that. Whatever I am teaching, that you understand. There are a lot more things to understand. You will understand. Still, you will have tomorrow class and day after tomorrow class. You can still ask. Write and come. Now also you take a book in your hand, book and pen, and quickly scribble some question you have. Okay? Keep doing that. This is the first part. So the lower the potential energy of the system, battery system, more stable it is. Hence, naturally the charges from the battery terminals move. And if there is provision from the positive to negative terminal or vice versa to attain more stability. This leads to the flow of energized charges. You know, battery will energize the charge and keep it ready. I hope I have explained this. Right. Energizes the charges. This leads to the flow of energized charges. So when the energized charges flow, it is nothing but electric current I. Okay, from one terminal to the other terminal through a suitable load. Okay, the load absorbs all the electrical energy from the charges. What did I say? All the electrical energy. Understand? So the charges that leave the battery terminal has some energy. The charges that enter the battery terminal has zero electrical energy.
So this is only applicable if there is only one load, sir.
If there is only one, no, many loads. See, this load I am showing you here can be many bulbs. You can have series of bulbs. You can have parallel bulbs. You can have the bulb and fan. Okay, you can have combination. One load I am showing.
Means if there is a bulb and another bulb, means this will absorb all the energy.
No, it will not. See, both will absorb all the energy.
Yes, sir.
Both will together absorb all the energy. Both together will absorb all the energy. Not only one bulb. This will eat. See, now your food is there. You will eat your food, and somebody, your friend, will eat another food. Understand? So both will have food. Both will eat. Okay? Understood? Okay. Right. Now look at this. What is voltmeter? Voltmeter measures the potential difference between 2 points. Okay? Voltmeter will show if there is potential. If you hold it here, zero potential. Understood? Okay. So somewhere where there is potential difference, it will show the potential. Alright. The voltmeter reading, say some X volts, must be interpreted as electromotive force of the battery under open circuit condition. Open circuit means it is not connected to any circuit. Then the potential difference at the ends is called EMF, electromotive force. Got it now? See, now don't get confused. Between 2 points, there is something called potential difference. Now you have to interpret the meaning of that. Understood now? You should interpret the meaning. Now it's not absolute thing. When the battery is open circuited, if you measure the potential difference, then it means it is EMF. Got it?
Yes.
That's it.
So if it is closed,
It is closed, it is the potential, it is the voltage of the battery. If in a circuit, it becomes voltage of the battery. If it is open circuited, it is EMF. Got it? Right. It means, now what does this reading X volts means? It means for every coulomb, the charge that comes out of this voltage source, it has X joules of energy. Every coulomb will have X joules of energy. A stone that is thrown from your hand, when it leaves your hand, has X joules of energy. Got it?
yes, sir.
Now when the stone leaves your hand, it has X joules of mechanical kinetic energy. The charge that leaves the battery will have X joules of electrical energy. Understood? It will also have kinetic energy, but that is not important for us. That kinetic energy is not at all used. It is redundant as far as electrical sciences are concerned. Right? So when the stone leaves your hand, what type of energy does it have?
Electrical.
When the charge leaves the battery, what type of energy it has? Electrical energy, not electrical kinetic energy. Did I say electrical kinetic energy? It is electrical energy. See, the charges in motion, okay, is itself called the electrical energy. Understood? Right. The number of charges that come out of every source every second, what do you call that as? Current. Strength of the current depends on the circuit to which it connected. So if you connect some load, right, then it will absorb some energy. Absorb some energy means it will absorb the charges, the energized charges from the battery. How many energized charges will come out of the battery? Well, it will depend upon the load. See, your mother will prepare food depending upon how much you consume. Correct? Isn't it? She will not make it more or less. She will not waste. She will make exact food. Same way, the battery food is there. It will give the food to the load as it consumes. I will tell you the mechanism of consumption. Cool. Now don't start thinking, so how does it consume? I have made slides. I know that today you are going to ask that question. Be happy. I have yesterday done a lot of research full day, and I have anticipated questions from all of you, right? And wonderful that yesterday you asked some questions. So I prepared appropriate notes. You will get all the answers for your question. Be happy. Now don't think forward and backward. Be with me in the class, right?
So it will absorb the energy means it will absorb the electrical energy.
Exactly. It will absorb the electrical energy only. It will not absorb the mechanical energy or any other energy. Okay? Right. Good. The number of charges that comes out of the source every second is current depends upon the circuit connected. Now I have shown a symbol of resistor. I think all of you can see. And we have discussed quite a bit about resistor, why a resistor is formed, what happens inside, etc. Now in simple, a resistor is a passive electrical component which offers resistance or opposition to the flow of electric current through it. Resistors of different values, 1 ohm, 2 ohm, 10 ohm, 1 mega ohm, can be manufactured. Okay, so whatever resistance you want, you can manufacture. Now you say 1 kilowatt heater coil. So in that the resistance is something. Or 2 kilowatt heater coil. Then the resistance is something. Iron box of this capacity, iron box of larger capacity. See, now in home domestic iron, you have a small iron. But now if you are a commercial that you want iron lot of clothes, then you will have a bada istri, then the resistance in that will be different. Now you have got 40 watt bulb, the resistance in that is something. Now you got 60 watt bulb, the resistance in that is something, etc., etc. So you can manufacture depending upon the load. Now you put a 40 watt bulb. 40 watt bulb means what? 40 watt bulb means what? Tell first. Good, Rajit. I'm so happy that you are answering. Yes, please continue.
Means it consumes 40 watts of energy.
It consumes 40 watts of energy means what? It consumes 40 joules of energy every second. 60 watt bulb means it will consume 60 joules of energy every second. Understood? That is the reading that you should take. It will consume that. So 40 watt bulb will consume 40 joules per second and give you some light. 60 watt bulb will consume 60 joules and give you more light. So it is more brighter. So depending upon the size of the room and why you want that room for, you will choose the bulb. Understood? You will appropriately choose the bulb. If it's a small room, honestly going for a big bulb is of no use. Or you are using that room only to store something, then you use a 40 watt bulb. Supposing you are reading, then you need a bulb which will give you more intense light. The brightness should be more. You will choose it. Understood now? So the resistors can be manufactured. Okay. Yes, please. Ask.
Sir, while consuming energy, sir, resistance create heat, sir.
Yes. I will tell you. I have got a slide. I will explain. Hold on. Now, first at this moment, it will consume energy. What happens to that energy? I will explain. It will get. I'll explain. Don't worry. Resistance, if it consumes energy, it will get converted to heat energy. But fan, if it consumes energy, it will not get converted to heat energy. It will get converted to rotational mechanical energy. Like that, it is different. Okay? Now we are dealing with resistors. It will consume the electrical energy and convert it into heat energy. So you see, don't see everything. Now you can see one circuit here, all of you.
Yes, sir.
So what do you see here? You see a battery.
Yes.
So for the sake of brevity, I have used the red line and green line here. Red matlab positive terminal, green matlab negative. And then I have connected a voltmeter. You can see there is a voltmeter here. I have connected a voltmeter. Voltmeter will not consume current. What did I say? First of all, understand. So then I have connected one resistor here. Can you see? Now what happens as soon as you connect, the current starts flowing. You can see current I is coming out, goes through the resistor and again goes back to the battery. Correct?
Yes, sir.
Now I have connected one more voltmeter to the resistor. In fact, this voltmeter is sufficient because both the voltmeters will give you same reading. But still, I have a reason to do that. For a given resistance R, as the current through the resistor increases, the opposition to the current proportionately increases. Now understand this very carefully, right? So I will conduct a small experiment and I will just show you what happens. Okay, right. So now you see I have this system here. I have got a duster and this. Now I am going to apply force. See now, okay. So now as it is, gravitational force is acting, right? But the gravitational force is balanced by the normal force on this duster. So the duster is at rest, right? Now you see, now I am tilting it. Now the gravitational force is still acting, but there is, the gravitational force has a component in this direction. Can you feel? See, it is going to slide. Why? That means gravitational force has got a component in this direction. Understood?
Yes,
but in this position, it is not sliding. If I make it still tilt it more, it will slide. Correct?
Yes, sir.
Why? So understand this. Understand this carefully. Okay? You will get a. Now this resistance I am teaching you is similar to friction. The voltage and all that you are learning is similar to friction electricity. So when I held the box like this on top of this, right? The mg was acting down and the normal applied by this on this was acting up, their equivalent opposite. Net force is 0. What did I say? So it is in good. It is in equilibrium and rest. Static equilibrium. Now I am going to keep it tilted. I am going to keep it tilted. Right? So as I keep it tilted, and then I am keeping the duster on this. Okay? So now you see the gravitational force is acting down, right? And the normal is acting like this. Normal will always be perpendicular to the surface. Hello, are you with me?
Yes, sir.
Now what happens? The resultant of these two forces is in this direction. Understood? So the resultant is in this direction. So what should happen to the duster? It should slide. It should slide. But it is not sliding. Can you see at this position? Hello? So why is it not sliding? Because why? Anybody can shout the answer fast. Yes, because of friction. So there is friction acting in this direction. Because of which, see, this frictional force will balance this net force. And therefore, it is not sliding. Got it now? Hello? Now, so it is not sliding. Now, further if I do like this, you see, it just starts sliding. Why? So, if I increase, yes, tell me.
Net force is greater than the frictional force.
Excellent, brilliant. So, in this condition, you see what happens? This frictional force is just equal to this and it starts sliding. Understood now? So, therefore, what did you understand from this experiment? Frictional force, when in this condition, frictional force is 0. In this condition, there is some frictional force. Okay? And in this condition also the friction. But the frictional force here, as you see, there is some frictional force. As you go on tilting, this net force keeps on increasing. And so frictional force also increases. You see here, what is happening here? The frictional force is 0, right? Now the frictional force is F1. Frictional force is F2. Frictional force is F3. Frictional force is F4. Frictional force is F5, F6, F7, F8. The frictional force keeps on increasing as you tilt. So it is a self-adjusting force. Got it?
Yes, sir.
We are all self-adjusting. But to a limit. If I scold you, you will take scolding. If I scold you more, you will take scolding. If I scold you still more, you will take. If I scold you still more, you will not take it. For everything there is a limit. Got it now? It is called limiting friction. Got it now?
Yes, sir.
Now, why I am telling you this is because, see, now the same thing happens in the battery. Okay, so this is the battery. And then I have connected the load R. So this will start sending the current. This will start sending the current to the load. The load will start opposing the current. If I start pushing you, you will start opposing.
Yes, sir.
Somebody pushes you. Initially, you will start opposing. To some extent, you will go back. You will go back. But you will not fall.
Yes.
For some duration, you are opposing and your opposition keeps on increasing as the person starts pushing you. At one point, his push is equal to your push. Understood now? He pushes, you pushes. At one point, his push is equal to your opposition. And then both of you are in equilibrium. Got it? He will not move, he will not move. Kusti. Like this Kusti, you know? Wrestling. Okay? Understood all of you? All this happens in the nature. Friction may wahi hua. The gravitational force is trying to pull it. The frictional force is trying to oppose it. And this goes on happening. At one point it says, I can't generate more friction. Then it starts sliding. Understood now? Same thing happens here. The current increases. As the current increases here, what will happen here? As the current increases, here what happens? The potential difference goes on increasing. I into R.
Yes, sir.
Huh? Resistance is constant. See, listen. What is resistance? Opposition. No, don't use the word resistance. Resistance of this material is 10 ohms. It is fixed. But the opposition to the current keeps on increasing. Got it? Now listen here. Opposition, resistance is R. Opposition is I into R. Hello, understood?
Yes, sir.
Opposition increases. See, as the current increases, the I into R will increase. See, this quantity will increase because this is fixed. I is increasing. Initially, assume that. Initially, as soon as you switch on, current increases. Current is 0. Current is 0 and it becomes some amperes. From 0 to 1, supposing current 0 to some amperes, it is increasing, no?
Yes, sir.
Right? It is increasing. As it is increasing, opposition is also increasing. As this is tilting, the opposition is also increasing. As somebody is pushing, the opposition also increasing. Got it, all of you? Increasing. So opposition increases. This opposition manifests. It shows up in the form of potential difference. What did they say? It shows up in the form of potential difference. So the potential difference here will also start increasing.
Potential difference will always remain same.
Wait a minute. That's what. Now there is something called as two conditions. Steady state condition, transient condition. What did they say?
Steady state condition, transient condition.
Understood? No? See, now you are standing, somebody suddenly comes and starts pushing you. And then what happens? As soon as that fellow pushes, the other person pushes, you will go back. But you are opposing and going back. At one point, what happens? His push is equal to your push. At one point, he starts pushing you, and at one point, you oppose, and at some other point, both of you are in equilibrium. Between he started and the equilibrium position, it is called a transient condition. He starts pushing, and then you start opposing. At one point, you start opposing, but when you are opposing, you are moving, he is moving. At one point, he stops moving, he will stop moving. But both are opposing each other. Opposition initially was 0 from your end. Opposition increased. So there is a time between your opposition was 0 to opposition is something. And then opposition continues. Understood? Same way, at one point the current is 0. Now the current from 0 to say I amperes, it has increased and it has remained now steady. It is in equilibrium. Got it? But between 0 to this, there is a transient condition. You take a plate and you drop it. At home, what happens? It breaks. Common sense idilla. One plate manage bitre muritade. Nindu ceramic plate alla steel plate. Sorry. So steel plate bitಕೊಳ್ಳೆ stop ಆಗ್ತದಲ್ಲ. It comes to steady state. The moment it falls from your hand till it comes to steady state, it is called transient state. ಏನಂತಾರಲ್ಗ? Transient state. Understood now? So you transit from your home to school. And now you are steady. Understood now? Transient. It is changing. Before it is attaining steady state, it is changing. Understood now? Transient. So during the transient condition, the current is increasing. From 0 to I amperes. So 0 to I amperes, the current is increasing, it is transient. Got it? During, as the current is increasing, what is increasing? The potential difference is increasing. I into R is increasing.
Yes, sir.
Hello?
Yes, sir.
As I into R is increasing, the potential difference is increasing. So what is the potential difference of the battery? V. Okay, I will take X. What is the potential difference of the battery? X. And this potential difference is increasing from 0 onwards. As current is increasing, it is increasing. At some point, this potential difference will also be X.
Yes.
Your opposite to your friend will also be C. But you know, at that point, current will stop increasing.
At the equilibrium.
At equilibrium. It will now remain steady. It will now remain steady. How much will be the current that will be flowing here? I will be equal to I will be equal to V by R. Understood?
Yes, sir.
This small I is transient current. Capital I is steady current. Got it now?
Yes, sir. Yes, sir.
Small I का मतलब है it is changing. Capital I का मतलब है it is steady.
Then
Get
how
it?
is small I equal to?
That is what. At time t. At time t is equal to t1, small I is equal to capital I. Good question. This small I is 0 at time t is equal to 0. At time increases, the current I will increase. At one point,
time both are equal.
both are equal. At the end, both are equal. And then it becomes steady state. Got it now? So that is the mechanism. Now it happens. So the battery starts giving charges. The charges, when it flows through the resistor, what happens? The potential difference keep increasing. At one point, the resistant potential is also equal to battery potential. Now current cannot increase or decrease. Battery will say, okay, I will give you constant current. The resistor will say, oh, you give me constant current. So both potentials are equal. It is in equilibrium. Got it now?
Yes, sir.
It continues to be in equilibrium.
Continues to be in equilibrium. Continues to be in equilibrium. V is equal to I into R.
Even when we switch off the
Even when you switch off, how it will be there? Even when you switch off, how it will be there?
no, someone's like
It don't know. Switch off means you have cut off the voltage supply.
it's a means
You have cut off. Hey, you see, this is the power source. This is the switch, and this is the load. Now, how much current is flowing? No current is flowing. Some common sense use ಮಾಡಬೇಕಾ ಬರೇ science ಅಲ್ಲ. So when I close this switch, what happens? This circuit is closed. Now current is flowing. Now once again, if I open this switch, no current will flow. Again, this voltage will become 0. Potential difference across the resistor will become 0. ಹೌದಿಲ್ಲ? Right. Okay, clear? Yeah. You can say that the transient period is almost 0. For all practical purpose, it is 0. Understood now? When you come to PUC and higher, that will become considerable and you will know how to calculate that. There is a very complex formula, etc. science, you will learn and you will do it. See, at some point it is insignificant. At some point it becomes very significant. Got it now? Otherwise it is negligible. But sometimes it becomes very, very important. See, medicine now. You take zyada, you take less. It becomes very significant. 1 milligram. See, tablets are 25 milligrams. 25 milligram is nothing. 1 gram andre ishta, 1 kaal akki. 25 milligrams andre 1 kaal akki the 1/4 part. Got it? So will it be significant when you are eating food? But tablet, if you take it, is significant. Got it? No? So science will tell you where what is significant, what is not significant. Understood? All of you? Yes, please understand this. Alright. So I suppose you understood the mechanism well. So you see the green color that I have written here. Green shading. The battery is trying to increase the current while the resistance is opposing the current. In the transient condition, the current stops increasing and becomes steady. I hope I explained this to you. Right. Okay. Now come to the next slide. Okay. Now battery, resistor, this is a closed system. जो कुछ भी एनर्जी बैटरी के अंदर है वही रेजिस्टर को जा रहा है. ठीक है ना? तो वो सब कुछ अंदरूनी बात है. हाँ. So it is called closed system. Energy is not entering from outside. Energy is whatever energy, chemical energy, it is getting converted into electrical energy. It is converted into electrical energy. Electrical energy is getting converted into heat energy in the resistor. Okay. This is a closed system. Energy is conserved. Chemical energy is converted to electrical to heat energy. And all these energies are joule, they are conserved. Output energy from battery is equal to the energy delivered to the loads.
Sir, but the heat energy is lost now, sir.
Wait a minute. Yes, good question. Wait a minute. Heat energy is still there in the system. See, now assume that I have got a chamber. Closed chamber. Heat cannot come, heat cannot go. In that I have kept a resistor and the battery. Heat is generated. It stays within it. In your microwave oven, what happens? Whatever heat is generated, it is within the microwave oven. Your bread is getting baked. But the heat is not coming unless you open the door. Who can I? Hello? See, same thing. Now the water heater, you have putting it in your water. And you switch on. Electrical energy is getting converted to heat energy. Heat energy is transferred from a heater to water. And water temperature is increasing. So is it coming out? No. If you take that water and put it on your body, then that will go into your body. Get it now? So it is within the system. It is not going. That is why we call it as closed system. Good question.
It is conserved also, you cannot reverse it.
No, let's not talk about reversal. You will have a topic called thermodynamics in first year PUC. So there you will talk about reversibility. And it's a huge topic. Right? You can write thesis on that. Thermodynamics. It's a big chapter. But see, these questions you are getting now, it is wonderful. Because all these questions, there will be answers in first PUC and second PUC. You need to learn more science. So if you want to know about reversibility and irreversibility, you should learn thermodynamics. See, some chemical reactions are irreversible. Some reactions are reversible. You know that now, right? Yes. So that is it. Reversible, irreversible. So it is possible. But under what conditions you will learn more science? Okay. See, dissipated means it is very difficult to reverse. Right. Output energy from battery is equal to the energy delivered to the loads. Why I am telling loads? You can see this circuit here. There is load 1 and load 2. Can you see here?
Yes, sir.
And I have connected 1 voltmeter there, 1 voltmeter here, 1 voltmeter. That voltmeter is Vs, source volts. V1, voltage across load 1. V2, voltage across load 2. Got it? Voltmeters will not take any energy. Right. Okay. Now, so energy is delivered to the loads. So whatever energy is coming out from the battery, it is going to both the loads. Now, how much each will take depends upon the value of the load. Now big brother, small brother. A 1-year-old brother of yours and you. So you will definitely eat more, your younger brother will eat less. Understand? Depend. Same way energy depends upon the load. Energy consumed depends upon the load.
Both the loads are same, then both of them.
Obviously.
Yes, sir.
Obviously. Right? The voltmeter across the battery measures the energy voltmeter across the battery measures the energy expended by the battery. Voltmeter across the battery. Now, voltmeter across measures the energy expended by battery for every column that it gives. If it gives more columns, it has expended more energy. X into X joules into Q. Q is the number of charges. Okay. The voltmeter across the loads read energy absorbed by the load for every column that goes through the load. Every column that passes through the load, it will, how much energy is absorbed by the load, that is what the voltmeter will give. Got it?
Yes, sir.
Already we have discussed this enough. Thank you. The voltmeter across the load reads energy absorbed for every column that flows through it under steady state condition. Vs is equal to V1 plus V2. What is Vs? Energy expended for sending one column. What is V1? Energy consumed for every column passing through. What is V2? Energy absorbed for every column passing through. Now these two energies are absorbed. V1 and V2 are absorbing energies. Vs is sending, delivering. So whatever is delivered is absorbed. Only thing is, see, in mechanics, energy given is equal to energy on this system plus energy on this system. Only small change. Now you start using energy per column. Understood now?
Yes, sir.
Ashta, confuse ಮಾಡ್ಕೋಬೇಡಿ. Total energy is equal to energy for total energy given by the source is equal to energy absorbed by the load 1 plus energy absorbed by load 2. But it now, ಇಲ್ಲಿ ಹೇಳಬೇಕಾದ್ರೆ this is correct. Whatever energy is given by the source is equal to energy absorbed by load 1 plus energy absorbed by load 2. Correct? But what does voltmeter do? Voltmeter will not measure the energy. It cannot measure the energy. Voltmeter is the instrument which can measure. Voltmeter is correct. It will measure what? Energy for every column. See, the energy meter in your home, KEB energy meter aitala mane olaga, that measures energy. That is not voltmeter. Voltmeter will measure energy for every column that is passing out. Got it now?
Yes, sir.
That is when you are connecting across a resistor or load. But if you are connecting it across a battery, it only measures potential difference. Because battery will not, simple open circuit battery is not giving out energy.
Yes, sir.
Only if you connect it in a load, it will give energy. Got it now?
Yes, sir.
So you understood V is equal to V1 plus V2.
Yes,
It is there are 3 loads. How much our load is there? That much. Understand now? Each load will take so much energy, you go on adding that energy. Law of conservation of energy. Energy is conserved. Understand now? जो energy battery से निकलता है, that is conserved. That is taken away by the loads. Now, I suppose this is clear.
Yes, sir.
Okay, done. Now, suppose the total of Q charges is delivered by the battery in interval of time delta t. I hope you understood.
Yes, sir.
In small amount of time, so much charges have gone. Yesterday I showed you with the duster, no? Like this. A total of Q charges is delivered by the battery in an interval of time delta t, and the current is I. So what is current I? Current I is equal to Q by delta t. Hello?
Yes, sir.
Now Q is equal to I into delta t. I is equal to Q by delta t. So Q is equal to I into delta t. Understood now?
Yes, sir.
The total energy possessed by these charges will be Q into Vs. Potential difference is Vs. Potential difference into charge gives you potential energy. This potential energy itself is the electrical energy. Potential energy itself is the electrical energy. Potential difference, correct. Vs stands for potential difference. Potential difference into Q gives you what? Potential energy of the charge. The potential energy of the charge at positive terminal with respect to negative terminal is Q into Vs. Say what I said.
Potential, why potential difference? Only potential multiplied by.
Correct. See, now understand this. Okay. See, gentlemen. So here you see this concept of potential difference you understand. Now, say this point is at some potential V1. Means what?
It has some potential.
So I have explained this. Now you take this table that you see here. The gravitation, see this pen is here. If I keep this pen on the table, its potential energy with respect to table is 0. Agreed?
Yes, sir.
Now if I take this pen here, the potential energy of this pen with respect to table is mgh. See, I have explained this. Your principal is asking me, what are you doing? I am telling them whatever I teach in 2 classes ago, they would have forgotten today because they are not working at home. So everything is, see, all this gravitational potential, that only I taught you for 1 full class. See, you have to absorb science. You have to go home and work, and you should be with science. Understood? Anyways. So the gravitational potential energy of this pen on the table with respect to table is 0. The gravitational potential energy of this with respect to table is mgh. Got it now?
Yes.
Now, if I divide this potential energy by m, then what will I get? Potential energy per unit charge, per unit mass. Got it now? Now, you see, this space, I am going to mark this point as having some potential. How much potential? GH, GH2, GH3, GH4. Got it now? So there is already potential. Means potential. You have got the potential to do well, man. You have got the potential to climb this building, man. That means you can. That means this point is capable of providing potential energy, provided you keep a pen here. The potential at this point is GH. If you keep a pen here, its potential energy will be mgh. Got it now?
Yes.
So, what is the potential difference between this point and table? GH. It is GH. So now you multiply matati. Now you say the potential at this point is V1. Potential at this point is V1 means what? This point is V1 with respect to table.
Yes.
This point is V2 with respect to table. So whenever you are saying potential, that means with respect to some reference, which you take it as 0. Now if I take the table potential as some x, then the potential of this will be what? X plus V, V1.
Yes, sir.
The potential difference will be what? X plus V1 minus X will again give you V1.
Yes, sir.
Understood now? So potential is always with respect to something. So when I say the potential difference between the battery terminal, that means potential of this with respect to this. Got it now? That's it. Potential difference and potential. Same. You have to understand the context. Okay? So the potential. So great. So here the energy delivered. So now here the total energy possessed by the charges at the battery terminal is Q into Vs. So Vs you treat it as potential difference or potential difference or potential of the positive terminal with respect to negative terminal. Got it? The energy delivered per unit time will be what? Q into Vs divided by delta T. Now Q by delta T becomes what? Current I. So it becomes I into Vs. So energy per unit time becomes power. So V into I becomes P. What is PS here? Power delivered by the source. Power delivered by the source. Power means what? So much energy per second I am going on giving. This second I give this power, this energy, then second. So see, as the bus is traveling, it is continuously expending energy.
Yes.
So if you now measure the energy consumed by the bus in motion, okay, per second, then it becomes the power output from the bus. Got it now? Like that. So power output. The power delivered by the battery, as per the observation, will be power delivered by the source is equal to power consumed by the load 1 plus power consumed by the load 2. So PS is equal to P1 plus P2. Is that all here? ಈಗ ಮರ್ತ್ಕೊಂಡು ನಾಳೆ ಕ್ಲಾಸಿಗೆ ಬಂದ್ರೆ ನಾ ಏನು ಮಾಡಕ್ ಬರುದಿಲ್ಲ. I cannot do. You have to work at home. You go home, write some notes, read something and come. And I am sending you videos and you are not seeing that also. Somebody else is seeing and asking doubts. You are not doing any work. You have to you have to manage your time. You have to become more efficient. ನೀವು ಬರೋಬ್ಬರಿ ಊಟ ಮಾಡಬೇಕು, ನಿದ್ದೆ ಮಾಡಬೇಕು, ಶಾಂತ ಇಟ್ಕೋಬೇಕು ಮನಸ್ಸನ್ನು ನೀವು ಕಲ್ಮಶ ಮಾಡಿಟ್ಕೊಂಡ್ರೆ ಇಫ್ ಯು ಆರ್ ಆಲ್ವೇಸ್ ಪಾರ್ಟ್ ಆಫ್ ಯು ಲೂಸ್ ಎನರ್ಜಿ. If you keep your mind calm and cool and say you have to dedicate yourself for learning, nothing else, no Chinese, nothing. If somebody tells, "Ee Chinese madida maavyak madbeka," what are to hanga Chinese madkondu kuda. Ee science istadav, so much things you have to learn. You have to learn so many things. You cannot do anything else other than studies. I am telling you. And you are all not brilliant students. You know what? I have seen students. You one book koda, one ವಾರದಾಗ ಓದಿ ಮುಗಿಸ್ಬಿಡ್ತಾರೆ. ಪಟ 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 ಹೇಳ್ತಾರೆ. There are some students like that. You are not like that. ನಿಮ್ಗೆ 10 ಸತಿ ಹೇಳಿದ್ರು ತಲೆಗೆ ಹೋಗಲ್ಲ. Because you are not loving science. The students who could learn fast, they were loving science. They were enjoying science. You are under tension. Exam, future. So don't worry about all that. Then you will put more pressure on yourself. You will lose more energy. Your concentration goes. Okay? Now don't forget all this. If you have any questions, ask it. Okay? Got it?
Yes, sir.
ನೋಡು, ನಾನು ಇಡೀ ದಿವಸ ನಿನ್ನೆ ನೀವು ಕ್ಲಾಸಿನ ಹೋದ್ಮೇಲಿಂದ ರಾತ್ರಿ 10 ಗಂಟೆ ಮಟ್ಟ ಕಂಟಿನ್ಯೂಸ್ಲಿ ಐ ವರ್ಕ್ಡ್. ಆಲ್ ಮೈ ಕುತ್ಕಿ ಎಲ್ಲ ನೋವು ಬಂದದ. ಫಾರ್ ನಿಯರ್ಲಿ 10 hours ಐ ಹ್ಯಾವ್ ವರ್ಕ್ಡ್, ರಿಸರ್ಚ್. ನಿಮ್ಮ ಕ್ವಶನ್ಸ್ ಆನ್ಸರ್ಸ್ ನಿಮ್ಗೆ ಹೆಂಗೆ ತೋರಿಸ್ಬೇಕು ಎಲ್ಲ ಮಾಡಿ. ನೀವು ಅದನ್ನ ಅಬ್ಸರ್ವ್ ಮಾಡ್ಕೊಳಕ್ ರೆಡಿ ಇಲ್ಲ. ಕಮಾನ್ ಗೆಟ್ ಅಪ್. if the loads are resistors, ಏನಂದೆ? Then Vs is equal to V1 plus V2. That is common for resistive load or fan load. Hello?
Yes,
Is equal to. Now what I am doing here, I am multiplying that equation throughout by I. Now Ohm's law, what it says? Voltage across is equal to current into resistance. Isn't it?
Yes.
Current is same. I is the same current flowing. Got it?
Yes, sir.
I is the same current that is flowing. Got it?
Yes, sir.
So I into R1 gives you V1. I into R2 gives you V2.
Yes, sir.
Now, as far as the voltage source is concerned, see here. As far as the voltage source is concerned, it will not matter the 1 hour load haka, 2 hour haka, 3 hour haka, 10 hour haka. None of what the total load is important. Understand? No?
Yes, sir.
The voltage source will say what the total effect. If supposing you will tell, so your mother will tell, see, first son wants 15 rupees, second son wants 20 rupees, third son wants 25 rupees, fourth son wants this much. Then the father is busy. He will say, "Arey yaar, totally how much you tell?" Totally. Then you distribute. Go. You will go and go now. Some fathers. Okay? Understood all of you?
Yes.
Right. A father who has many children and he has lot of work, you will do like. Same way this voltage source. Arey yaar, load 1, load 2, load 3, 8 hour load ಇಲ್ಲ. Total load ಎಷ್ಟು? ಹೇಳಿದಲ್ಲ? That the total load seen by the voltage source is Req. Req ಅಂದ್ರೆ R equivalent of many loads. Got it?
Yes, sir.
Sum of many loads, like V1.
No, sum ಅಂತ ಹೇಳಿಲ್ಲ. Sum ಅಂತ ಹೇಳಿದ್ದೇನೆ.
No.
What the voltage source is the wholesomeness. The total load. I didn't say sum.
Yes.
It is the total load seen by the voltage source. Just I gave you an example. Father says, don't tell me ಅವಂಗ ಅಷ್ಟು ಬೇಕಾ ಇವಂಗ ಇಷ್ಟು ಟೋಟಲ್ ಎಷ್ಟು ಬೇಕಾ ನಾ ಕೊಡ್ತೀನಿ, ಕೊಟ್ಟು. Okay, so again total of 40 rupees bakery. Mother will tell father total 40 rupees bakery. He has 50 rupees note, he will give. 10 rupees just need it to go. He will tell no. But voltage source is not like that. Need to go, he will not tell. 40 ಅಂದ್ರೆ 40 ನ ಕೊಡ್ತೇವೆ. ತಿಳಿಸಲ್ಲ 41 ಅಂದ್ರೆ 41 ನ ಕೊಡ್ತೇವೆ. ಚಿಲ್ಲರ್ ಪ್ರಾಬ್ಲಮ್ ಇಲ್ಲ ಅದಕ್ಕೆ. ತಿಳಿಸಲ್ಲ? So it will give full, correct?
So REQ is the total load of what?
See, now there is load 1, load 2. In this case, REQ stands for the load 1 plus load 2. In this case, it is the total load is load 1 plus load 2. In this case. In this case, it is load 1 plus load 2. In other case, it is not load 1 plus load 2. It is something else I will tell you. Understood now? So in this case, it is and load 1 plus load 2 is seen by the source, and the total load that it sees here is REQ. Got it?
Yes, sir.
So I have done a manipulation here. I have multiplied this equation. See, what is Vs? What is V1? V1 is I into R1.
Yes, sir. Yes, sir.
What is V2?
I into R2.
And the left side also, instead of Vs, I wrote it as I into REQ. Instead of Vs, I wrote it as I into REQ. So I is the current coming from the source, and REQ is what the load seen by the source.
Yes, sir.
So I just manipulated. It's called manipulation. Got it now? So I did that equation. Now I can cancel I.
Yes, sir.
Then I will get what? REQ is equal to R1 plus R2. So what is REQ? The sum of the resistive loads. If it is a resistor. If it is fan load, you can't do this,
Yes, sir.
It is fan or something else, it will not. Understand? This is resistive load. So now here you see students. The same current I is flowing through the loads. Can you see here?
Yes, sir.
Which current? जो इलेक्ट्रॉन बैटरी से निकलता है वही इलेक्ट्रॉन लोड 1 में घुसता है और वही इलेक्ट्रॉन लोड 2 से बाहर आता है, वही इलेक्ट्रॉन लोड 2 में घुसता है और वही इलेक्ट्रॉन लोड 2 से बाहर आता है.
Yes, sir.
Yes, sir.
Understood now? It will go through the same load. When the same current is flowing through both the loads, what did I say? Same current. Then the loads are said to be connected in series. Then the loads are said to be connected in series. Arthatala?
Yes, sir.
This definition is important because I am going to tell you some other combination of loads.
Are connected in series.
The same current is flowing through both the loads. Then they are said to be connected in series, one after the other. See, man, look at this, man. If the same current is flowing through both the loads, no?
Yes, sir.
Then we say the loads are connected in series.
So, one doubt, so if those loads are like in the series, same current is flowing now. If load 1 is a resistor and load 2 is
Now don't ಅದೇ ಹೇಳ್ತಿರೋದು ಈಗ ನೀನು ತಲೆಹರಟೆ ಮಾಡಿದ್ರೆ ಪ್ರಾಬ್ಲಮ್ ಆಗ್ತದೆ. ಲೋಡ್ ಅಂದ್ರೆ ರೆಸಿಸ್ಟರ್ ಆಗಲಿ ಫ್ಯಾನ್ ಆಗಿರ್ಲಿ ಅಂತ ಹೇಳಿಲ್ಲ ನನಗೆ. Load 1 can be resistor, load 2 can be fan. Understood? No?
yes,
Loads are in series, I told. What did I say?
loads are in series.
When are the loads in series?
When same current is flowing.
Understood? No? So load is load. Now, load can be resistor. So it can be resistor and fan, they are in series. It is resistor and resistor, they are in series. Understood? No?
Yes, sir.
So, but that R1 plus R2 equal
Wait. Understood now? Fish point? Now come. Now, if both the loads are resistors, then these equations will come. Bardarallo, clear ಆಗಿ
No, only if the loads are resisted. If they are like
ನೀಸ್ ಬರೋಬರಿ ಮಾತಾಡ only
only if the loads are resisted, it is true. No, so but if
wait. Irrespective of resistor, the same current is flowing. Then the loads are in series. Got it? Over. One part over. Now come to the next part. If the loads are resistors, again they are in series. So they are in series. Problem solved. Now, if they are resistors, then you can apply Ohm's law. For fan load, you can't apply Ohm's law directly like this. If they are resistors only, you can apply Ohm's law and you can write I into R. If there is fan load, you cannot write I into R. Got it?
Yes, sir.
That is what I meant. But either differences load can be anything. Now, if the load is resistive, then Ohm's law will come to picture. Then you can write this equation. Got it?
Yes, sir.
ಯಾಕೆ ಇದನ್ನ ಹೇಳಕತ್ತೇನಂದ್ರೆ unless you give importance to this, ನಾಳೆ fan tomorrow when you come to PUC, you have to use fan load and other types of loads. ಅಲ್ಲಿ ನೀವು ಈ equation ಬರೆದ್ರೆ ಮಟ ಆಗ್ತದೆ. So you can apply Ohm's law and you can get this derivation. Req is equal to R1 plus R2. If there are 3 resistors, R1 plus R2 plus R3. Equivalent resistors. Got it?
Yes, sir.
Are connected in series. Clear?
Yes, sir.
Okay.
Sir, can those be like bulbs and bulbs?
3 bulbs can be correct. 3 bulbs, all bulbs are resistive load. Then it will be bulb 1 plus bulb 2 plus bulb 3. Resistance of bulb 1 plus resistance of bulb 2 plus resistance of bulb 3. Correct. Okay? Online students?
Yes, sir.
Clear?
Yes. Yes, sir.
ನೋಡ್ರಿ ಇಷ್ಟೆಲ್ಲ ನಾನು ಡೀಟೇಲ್ ಕಲ್ಸಾಕತ್ತೀನಿ, ಮಸ್ತ್ ಮಾಡಿ ಎಲ್ಲ ಕಲ್ಸಾಕತ್ತೀನಿ, ಮಸ್ತ್ ಕಲೀರಿ. ಈಗ ನೀವು ಕಲೀಲಿಕ್ಕೆ ಮುಂದೆ ಬರ್ಲಿಕ್ಕೆ ಗಾಡ್ ಸೇವ್ ಯು. Now don't blame anybody. Don't blame your parents, don't blame your school, don't blame our country. You have to blame yourself. So better dig yourself down and work. And don't fall sick. That has become a reason for all of you. And when online classes are there, why you should miss class? Button ottadaithi nodudaiti. Naan jara bitkondu exam barad bandini. There are many students. They walk 8 kilometers, 10 kilometers every day. In rain, in snow, you have seen? ನಿಮ್ಗೆ ಏನು ದಾಡಿ ಐತಿ, ಮನೆ ಒಳಗೈತಿ, ಹೊದ್ಕೊಂಡೈತಿ, ಆನ್ ಮಾಡೋದೈತಿ, ನೋಡೋದೈತಿ. So I am not well, I will not be attending class. What is that nonsense? That will not be tolerated. You have to attend the classes. I have made all the provisions for you. Offline, online. You cannot miss the class. I am telling all of you. Understand? ಮನೆ ಒಳಗದ ನಿಮ್ಗೆ ಯಾರು ನೋಡ್ತಾರ, ಏನು ಹೊದ್ಕೊಂಡು ಕೊಡ್ರಿ, ಏನಾರು ಹಾಕೊಂಡು ಕೊಡ್ರಿ, ಇಲ್ಲ ಹಂಗ ಕೊಡ್ರಿ. ಕ್ಯಾಮ್ರಾ ಆನ್ ಮಾಡಬೇಡ್ರಿ ಅಷ್ಟೇ. Now, voltage across the battery is equal to voltage across the resistor is equal to I into R. Understood now? In what case? If your loads are resistors. No. Loads are resistive. Correct. Power supplied by the battery is equal to power dissipated in the load. Got it? Now, second issue. See, I am now coming to this diagram. Coming to this diagram. Got it?
Yes, sir.
Understood? Now, power supplied by the battery is equal to power consumed by the dissipated in the load. What is the power supplied by the battery? V battery into I. And what is the voltage across the resistor? V resistor into I. Both V's are same.
Yes.
I'm just differentiating it. Got it now? Now, so V of the resistor, what is V of the resistor? I into R.
Yes, sir.
Into one more I. I V resistor is converted into I into R. Got it?
Yes, sir.
So you get I square R. What is I square R?
Power.
Power. V into I is power.
Yes,
V का दूसरा रूप I into R.
Sir, once again, can I repeat?
See there, you can see. Whatever is written, I have written. This V of resistor, I wrote it as I into R. Because Ohm's law is applicable. If Ohm's law is not applicable, you cannot write.
Yes, sir. You wrote there in bracket heat energy, sir.
Wait. I have not yet come to that point. So you get here I square R joules. What is this? This is the power dissipated in the resistor.
Yes, sir.
And this is equal to power delivered by the load. Now, this power that is dissipated will get converted into heat energy. Understood? First the power is dissipated, then it will get converted to heat energy. What is your question?
No, sir, means for, if we write power supplied by the battery, we must write as electrical energy. No, sir, means I was gonna ask the same. Means what you just told, I was gonna ask.
Understood now? Okay then. ठीक है?
So like the I square R is for only resistor, no, sir? For battery it cannot be I square R. It is both same, but we cannot use R because resistor will not be there, sir.
You are not learning science, man. You are by-hearting. Your question has no meaning. Senseless. Totally senseless. See, your problem, I'll tell you. Now it is 7:30. You cannot concentrate after 20 minutes. 25 minutes afterwards, you cannot, I'm watching you. First half an hour, you are very receptive. Afterwards, you stop. Afterwards, half, quarter, understanding. You have to change it. You have to know how to concentrate. It's a problem for you. What am I trying? See, I have written everything in bold letters here. Power supplied by the battery is equal to power dissipated in the load. So you should go from left to right. What is the left thing? Power supplied by the battery. See, you learn how to read it. V battery into I. What is this? Power supplied by the battery. Battery ने power दे दिया. क्या हुआ वो power? That went into the resistor. What happened in the resistor? That the power is dissipated in the resistor. So this is telling you power given by the battery. This is giving you power that's given to the load, absorbed by the load. And then I am manipulating. What am I doing? Manipulation. What am I doing? The voltage across the resistor, I am writing it in I into R as per Ohm's law. And then what I am doing? I am multiplying this I's. I get I square into R. And what is this I square R? I square R is, what is I square R? The power dissipated in the load. Now this is how much power? Whatever power was given by the source is dissipated in the load. Illiga nindu question ena?
Like in battery, like and IR is when the power is consumed by the IR square. I square R is when the power is consumed by the resistor.
Why are you using the word when it is consumed? Why are you using the word? Why are you using that word? What is your why are you using that word? What is the reason?
Like V battery can also be written as I square R.
How you can write? Why do you want to see? Why do you want to write that? You tell me. Why do you want to write V battery as I square R? Why you want to write? Alwas ಏನಾದ್ರು ರೀಸನ್ ಇರಬೇಕು. ಸುಮ್ಮನೆ ಏನೋ ಒಂದು ಬರೋದು ಅದನ್ನ ಯಾಕೆ ಅದಕ್ಕೆ ಹಾಕಬಾರ್ದು ಅಂತ ಕೇಳಬಾರ್ದಂಗ. ಈಗ ಸಾಂಬಾರ್ ಮಾಡ್ತಾರೆ, ಸಾಂಬಾರ್ನಾಗ ನಾನು ಯಾಕೆ ಬೆಲ್ಲ ಹಾಕಬಾರ್ದು ಹಂಗೆಲ್ಲ ಕೇಳಬಾರ್ದು. ನೀನು ನೋಡ ಅದು ಒಂದು ಈಕ್ವೇಶನ್ ಒಂದು ಇದು ಬರೆದ್ರ ಒಂದು ಅರ್ಥ ಇರ್ತದಪ್ಪ. ನೀನು ಅದನ್ನ ಸಿ ಈಗ ನಾನು ಏನು ಬರ್ದೇನೆ ಬೋರ್ಡ್ನಾಗ ಅದು ವೈ ಯು ವಾಂಟ್ ಟು ರೈಟ್ ಬ್ಯಾಟ್ರಿ ಆಸ್ ಐ ಸ್ಕ್ವೇರ್ ಆರ್ ಯು ಟೆಲ್. ವೈ ಯು ವಾಂಟ್ ಟು ರೈಟ್ ಯು ಟೆಲ್. If you have reason you tell.
Like both equations are equal.
Equations equal allo. This is not maths class. This is physics class. Whatever you have, something happens. No, that physicality we are converting it into a mathematical model. See here, you try to understand. This is here. This should be understood as power given by the battery. This should be understood as
Power dissipated.
this equal to sign in physics means this physical quantity is numerically equal to this physical quantity. You should know. Hello. See, this physical quantity to the left is power given by the battery. This quantity is power consumed by the load. There are two different powers. Numerically they are same.
Yes.
Understood? No, see, yes. Physics ಒಳಗ ಬರಿಬೇಕಾದ್ರೆ ಎರಡು ಪಾರ್ಟ್ ಇದ್ರು ನ್ಯೂಮರಿಕಲಿ ದೇ ಆರ್ ಈಕ್ವಲ್ ಇದ್ದಾಗ ಈಕ್ವಲ್ ಟು ಸೈನ್ ಯೂಸ್ ಮಾಡ್ತೀವಿ. ಒಂದು another thing is if both are the same physical quantities we use equal sign. ಇದು ಪವರ್ ಇದು ನ್ಯೂಮರಿಕಲಿ ಈಕ್ವಲ್ ಇದು ನ್ಯೂಮರಿಕಲಿ ಈಕ್ವಲ್ ಅವಾಗ ಈಕ್ವಲ್ ಟು ಸೈನ್ ಯೂಸ್ ಮಾಡ್ತೀವಿ. ತಿಳಿತಲ್ಲ? ಬಟ್ ದಿಸ್ ಈಸ್ separate and this is separate. This means separate, this means separate. Is that clear?
Yes, sir.
See, ಅದಕ್ಕೆ ಹೇಳ್ತಿರೋದು ಅದನ್ನ ಹೇಳ್ತೀನಿ ನೋಡಿ ಮಕ್ಕಳ, ನೀವು ಸೈನ್ಸ್ ಅಂದ್ರೆ ಮನಸ್ಸು ಕೊಡ್ಬೇಕು ಅದಕ್ಕೆ. ದಿಲ್ और दिमाग का इस्तेमाल करना, कोशिश करना. ಬಾಯಿಗೆ ಬಂದಿದ್ದು ಹೇಳುವುದಲ್ಲ, ಏನ್ ಬೇಕಾದ್ ಬರ್ದಿದ್ದು ಏನ್ ಬೇಕಾದ್ರೆ ತಿಳ್ಕೊಳ್ಳೋದಲ್ಲ. ಅದಕ್ಕೆ ಪ್ರಾಬ್ಲಮ್ ಆಗೈತಿ ಈಗ. See, everybody is talking, how to improve education, but education means this. You have to involve yourself, students and teachers. Understand? ಇದು ಬಂತು ಸೈನ್ಸ್ ಬರ್ತದೆ. Involvement. You have to understand this, okay? But anyway, I appreciate this boy because he comes out with funny questions. I come out with funny answers. You know, okay? Clear?
Yes, sir.
So physics ಒಳಗ the quantities we write have to be interpreted. They are not absolute. They have to be. See, each one of us. Today I am a good man. Doesn't mean that tomorrow I will be a good man. But the probability I will be a good man is very high. That doesn't mean that 100% I will be a good man. Got it, all of you?
Yes, sir.
Please understand, that is what is education. So education tells us to think and act. Education tells us to think and act. Everything will not be same every time. Your father is a good father because he doesn't put his little finger in your nose. Yesterday he didn't put. Today if he puts, he will be a bad person. Understood? No? That is how you should learn. Cat is a cat because it has the properties of a cat. There is nothing like absolutely he is good and he is bad. Under these circumstances, under that context, he is good. Probability he is good is very high. That is different. That is why we come to the statistical feature. Tomorrow you are going to come to the class because the probability I will be good tomorrow is very high. Understood? If it is very low, then you will come with some bodyguard. Understood? Life is like that. So you have to interpret and learn. Okay? Done. Okay, understood?
Yes,
Yes, sir.
So this is I square R is dual. Now here you see what is I V into V by R. So I square I will convert it into V square by R square.
Yes, sir.
Then what will have V square by R square into R. One R will cancel. So you will get V square by R. Understood?
Yes, sir.
You can write it as V square by R.
Yes, sir.
So you see here, you have got a voltage source whose potential difference is V. And if you connect a resistor R to it.
Yes, sir.
Got it?
Yes, sir.
See here. So you have got a voltage source of V volts. And if you connect a resistor R, then how much power is delivered to R? V square by R. You have R and you have V. You don't have to calculate current.
Yes, sir.
But actually it is because of the current it is happening. But this is called as manipulation. With these two values, you can get it.
Yes, sir.
Understood? Yeah.
So, Ramesh, can you write how you got V square by R sine?
Okay, I'll write. Now, V is equal to I into R. Hello?
Yes, sir.
So now here, power. Power on the resistor. Right?
Yes, sir.
So V across the resistor into I through the resistor. V through the resistor into I through the resistor. Got it?
Yes, sir.
No, sorry, I'll write that. No, V through the resistor. I can write it as I through the resistor into R. Into IR. Got it?
Yes, sir.
V is equal to I into R. So this becomes what?
I
IR square into R. Now, here you see. Here you see, I converted VR as I into R.
Yes.
Now, what I will do, I will write like this. So here you see, VR as it is. IR is what? VR divided by R.
Yes, sir. Yes, sir.
I is equal to V by R, no man.
Yes, sir. Yes, sir.
Yes, sir.
Yeah.
Yes, sir.
So it becomes VR square by R.
Yes, sir. Yes.
Pardon?
Yes, sir.
Okay, shall I proceed?
Yes, sir.
A series parallel moves become ಬಂದೇನೆ. Okay, so I think till this point it is clear.
Yes, sir.
Now, one more version of this. See, quickly see. This is nothing to be explained. I have already explained. The nature of every circuit is battery delivers power to the resistance such that the potential difference across the battery V1 does not change for it. So now look at this circuit. Potential difference across the battery V1 will not change for any value of the resistor. Got it?
Yes, yes, sir.
Then current through the resistor obeys Ohm's law.
Yes, yes, sir.
Okay? V1 is the voltage across the resistor divided by R. Current at all points in the circuit is I. Means what? You keep ammeter anywhere, it will show same current. Power delivered is equal to power consumed. V2I is equal to V1I.
Yes, sir.
And therefore V1 is equal to V2. So both the voltmeters will show same reading. Got it?
Yes, sir.
Power delivered is as per conservation law. Now V1 minus V2 is equal to 0. Got it?
Yes, sir.
What does it mean? If you go in a loop, If you go in a loop, loop means you start from here, go like this and come back here.
Yes, sir.
Loop. If you go in a loop, the power that is given will be equal to power that total power given will be equal to total power consumed. What did I say?
Total power given will be equal to total power consumed.
Or in other words, total energy given is equal to total energy consumed.
Yes, sir.
Or in other words, total energy per coulomb given is equal to total energy per coulomb consumed. So total energy per coulomb becomes voltage. So this समय the algebraic sum of the voltages. क्या बोला मैंने? Now understood the meaning?
Yes, sir.
Algebraic sum of the voltages in a closed loop. इसको क्या बोलते हैं? Closed loop is 0.
Yes, sir.
So that is V1 minus V2 is equal to 0. Now there are many sources. Source 1, source 2, source 3. You have to algebraically add them. क्या बोला मैंने? Algebraically add means, you see, this is voltage source 1. This is another voltage source V2. Hello.
Yes, sir.
Now what is the total voltage here?
V1
V1 plus V2. Now, this voltage source is V1, this voltage source is V2. Now, what is the voltage source of this point A with respect with point B? Voltage of point A with respect to B. V1 minus V2. Got it down?
Yes, sir.
Algebraic means you have to add with sign.
Yes, sir.
Understood now? Algebraic means you should add with the sign.
Fine.
So this becomes the total.
Why minus V2?
Because see now here. See now if you take the current here. Supposing you are connected to the load. Supposing you are connected to the load. Current would have traveled like this. Down. Okay, down. And then it will come here. But what happens here? This is at a higher potential with respect to this. So this battery will oppose the current. It will oppose the current. It will not consume energy. It will oppose. Understood now? It is not like resistor. Resistor will oppose and it will consume energy. It will get converted to heat. Here it opposes. It might consume energy. It consumes energy. Hello? It becomes negative energy. It consumes energy, not that. But that is not converted to heat energy.
Yes.
Understood? That is not converted to heat energy. Understood? What happens with that energy? It will get converted into some chemical energy. If it is a chemical cell. It is not a chemical cell, something else will happen. Now don't bother about it. You will learn in higher classes. All that you know is it opposes, and so the total voltage will be V1 minus V2. If it is like this, it is V1 plus V2. Got it? Like this, it is V1 minus V2. Got it?
Yes, sir.
Right. Okay.
Sir, how do we get to know which one is that higher?
ಇದು ಉದ್ದ ಇದು ಸಣ್ಣ ಕಾಣಂಗಿಲ್ಲ.
No, sir, like,
ಉದ್ದ ಲೈನ್ ಸಣ್ಣ ಲೈನ್ ಕಾಣಕತ್ತಿಲ್ಲ. ಉದ್ದ ಲೈನ್ ಅಂದ್ರೆ ಪಾಸಿಟಿವ್ ಟರ್ಮಿನಲ್, ಸ್ಮಾಲ್ ಲೈನ್ ಅಂದ್ರೆ ನೆಗೆಟಿವ್ ಟರ್ಮಿನಲ್.
yes. No, sir, like A and B.
I told potential of A with respect to B. Potential of A with respect to B will be V1 minus V2. Potential of B with respect to A.
V2 minus
V2 minus V2. ಅಂದ್ರೆ ಆವಾಗಲಿಂದ ಬ್ಯಾಟರಿ ಹಿಂಗೆ ಕನೆಕ್ಟ್ ಮಾಡಿ ಕರೆಂಟ್ ಹಿಂಗೆ ತೋರಿಸಿ ಉಲ್ಟಾ. V2 minus V2 becomes prominent. Understand this?